Hey everyone, welcome back to Enabled. If you've been following along, you know that we've been working on a modular controller that we can use on several different systems with different peripherals to use, buttons, switches, whatever you need that can accommodate your needs. And if you've made it this far, you might be wondering, okay, well, how do you interface with the actual system? And in this video, I'm going to show you exactly how to do that. What we're going to do is, this is a Sega Genesis Mini controller. And we're going to take this apart and we're going to hack into it so that we can plug it into our modular controller, and the buttons and joysticks that we use with that controller will work directly with the Sega Genesis Mini. Now for you detail-oriented people, you're going to see that this controller that I'm holding right now is a little bit different than the one that I modify. The one that I modify is the exact same thing. It's a real Sega Genesis Mini controller, but it has the extra 3 buttons on the top. And the reason that I'm not holding that controller is because I forgot to create an introductory video, and I've already torn that controller apart and there's nothing to hold and show you anymore. So let's pretend that I didn't screw it up and continue on. Okay, so I'm going to try and tear down this Sega Genesis Mini controller and see if we can't hack into that and get it to work with our controller. So there are 1, 2, 3, 4, 5 screws. Back pulls off. See what we have here. Got a little mode button that we need to pull out. Set that aside. And the PCB just pulls straight up. Okay. And this one, is that a connector? Well, maybe not. Alright, and this is what the top of the board looks like. So we have our directional pad here, up, left, down, and right. This is the start button. Yes. Start button in the middle, and then we have our 3 lower buttons, 3 upper buttons. So the first thing I need to know is this a common ground board? So let me do some probing on this and we'll see. I got done probing, and this board is in fact common ground, so that's good. Now how did I figure that out? Well, I have a multimeter here, and I just put it in the beep selection so that when I touch the 2 probes together, it beeps. And then I go to each one of these button pads. So each one of these button pads has 2 conductors on it. And when you press down a button, there's a little conductive piece inside of it, and when you press the button down, it pushes that conductive piece down onto the button pads and connects those 2 halves together. And then I went through and I know that one side of each button is a positive signal and the other side of each button is the negative ground. And I wanted to see if all of the grounds were connected. So I just touch one side of one button pad, and you take my other probe and I push on the on one of the button pad terminals, and if it doesn't beep, then they are not connected. If the other side beeps, then it's connected. So now I know that these two terminals are connected, and those are most likely ground. And then I do that for every single button pad. So that's two, that one's connected, that one's connected, that one's connected. I've got a couple grounds up here. This terminal right here, which is the ground coming in from this cable, is also grounded. So then I go to the start button, and that pad's connected. Then I go to the directional pad, that's connected, that's connected. That one's connected, and that one's connected. So that's all of my buttons. They're all connected to the same ground plane, which is what we're looking for. Now, this controller also has little solder pads. See if I can get it up here so you can see. This controller has little solder pads for all the positive lines, and you gotta kind of follow the traces, or you can do the ring out on these pads to this pad to see what's connected that way. But this is what we're going to solder our wires to. So what we're going to do is we're going to connect one ground wire, most likely to this terminal right here, because it'll be easier to solder to. We could also pick one of these solder joints that are also ground. It doesn't really matter. As long as it's on the ground plane, we can pick it up anywhere we want. And then we're going to solder individual wires to each one of these pads that correspond to each button. And then we'll need to wire that up to our project box and then hook it all together and see if it works. So let me go ahead and get the individual wires soldered on, and then I'll pick up from there and show you how to connect it to the box itself. Now that we're ready to solder wires onto our controller board, I'm going to kind of streamline how I connect this board to our modular controller. The way I'm going to do that is in the modular controller, we're going to have a DB25 connector like this. And on the inside, there's going to be block terminals that we can easily put wires in and screw down so that we can reduce the amount of soldering that we're going to do. And then on the outside, we're going to interface with this connector right here. Now this connector is kind of, I hesitate to say obsolete, but these are the kind of connectors that you used to see on old printers, a lot of the old analog devices. These type of connectors were very common. Nowadays they've been replaced with USB and digital signals, but they're still easy to get. The cables are readily available, and they're about the same price as an HDMI, which is what I originally planned to use, and then my hopes and dreams were shattered. So I've switched to this D-sub-25 cable here, and this is a male on both ends, and our connector that goes into the modular controller is female. So these two will mate together. Now what I'm going to do is take this cable here, and I'm going to cut it in half. And it doesn't have to be exactly in half, close counts. In fact, I think there's more than enough cable here to do what we need to do. So what's going to happen is I'm going to take this end that I cut off here. I'm going to cut the shielding back, and I'm going to peel all this away and expose all this bundle of wires that's inside. This is going to stick outside of our project box, which I have right here, we're going to mount our controller board inside of this box, and then we're going to stick the cable in there, and we're going to wire the wires that are in this cable up to our board. This is going to come out, and then we're going to connect this guy into our modular controller. So let me get this cable stripped down, and then we'll try and figure out what pin does what. Okay, I've got my cable cut in half, and I got all of the shielding cut off and stripped down. Inside you're going to find aluminum shielding and some braiding. We're just going to toss that in the trash. I also stripped the end of every wire so that I can probe and figure out which wire goes to which pin on our board. Now, this breakout board that I have has all of the terminals labeled. So we start at 1 over here, and we go all the way to 13 on this side, and then the opposite side we have ground on this end all the way to 25 on this end. So that's really convenient. I did look up on the interwebs, I looked at a Breakout to see if these are standard, so if the colors are standard to the pins. And I did find something online that does indicate that that this is some kind of standard color code, which is good. But I also found a couple different ones that were different colors. So if you do this, you need to verify that if you do find something online with the color coded to the pins, that the information you're using is correct. And that's really easy to do with this setup with a multimeter. So I've got the multimeter set in beep mode, and I'm just going to pick up a random wire. So this is a yellow wire here, and I'm going to put that on one terminal. I've got my cable plugged into my breakout board, and so with the black terminal held against the yellow wire, I'm just going to go terminal by terminal until I hear a beep. There it is. So that tells me that the yellow wire is pin number 5. So now that I know that, I need to figure out how I'm going to route it into my box. And what I mean by that is I need to drill a hole in the end of it so that I can insert my bundle of wires into my box. And I need to do the exact same thing for my controller wires bundle. So I'm going to drill 2 holes in the end of this box, get my wires routed through there, and then I will solder the wires onto the pads. This is what I'm talking about. So I've got my USB portion of the cable here, which was attached to the board. I cut that off because I need to route that USB wire through my box, and then when I have everything situated, I'll solder these wires back together, and then everything will be tucked inside and will be really clean. The D-sub-25 connector, I have the same way. I've got it running through my box. I've got it routed through my box. All my wires are frayed out here, and those are the ones that I will solder onto the solder pads. I have got cable glands for each of these cables. That helps strengthen the cables coming out of the box. I have pulled the cable as much through the box as I need to, so that I have plenty of slack to solder my points here on the bench. When I have all that done, I'll just slide my cable back out, and then I will tighten these glands here, and then the cable will be stuck in that position. The reason you want to use these glands is because you just have to assume that accidents are going to happen, and these are going to want to pull. You'll be pulling these, or if somebody trips over them, it'll yank that out. And you don't want to be pulling on any of your solder joints or pulling on the board itself. So This is just a way to robustly put your cables in so that you can pull on them and it won't damage anything. So I'm going to go ahead and get these wires soldered to my board pads, and then I'll solder my USB connection back together, get it all mounted in here, and see what it looks like. Here's one last look of the finished product before getting it mounted inside the box. So you can see that I've got all the wires soldered to the board. Now these can be really fragile, and it's not always the solder joint itself that's fragile, but the pads will actually tear off of the board itself. So you want to be really careful. Don't move it around a whole lot after you get the wires soldered on. The unused wires I just kind of bundled together and put some electrical tape on the end of them just to keep them out of the way. And then I did solder my USB wires together, so that's good to go as well. So now what I'm going to do is cover all these joints in hot glue, and that's going to keep them down and it's going to strengthen them so you don't have to worry quite as much about moving it around. And then I took the bottom of the controller, so this is what we took the screws out of this to separate the controller, and I'm going to use that. I trimmed it so that it would fit inside of my box, so I cut both sides off a little bit, and I'm going to mount the board onto the back of that controller just like that. I'm going to put some screws into the existing holes. And then I'm just going to hot glue this entire bottom tray down in the bottom of the box. And that'll allow me to have a really rigid connection down there. It'll be really clean. And if I did want to remove the board in the future, I could just remove the screws and the board will pull out again. One last thing is when you get your wires all soldered up, it's a good idea to wring them out. So I connected my connector to my breakout board, and then I just probed each button to the pin that it's supposed to be and made sure that everything rang out the way it should be. I also put my probe on ground and then went through and touched each pin on the board to make sure that nothing was shorted to ground, and it isn't. So as far as I can tell, everything is wired correctly. There's nothing shorted out, and this should work. So the next step is to get it all mounted in the box and button it up. Let's take one last look at our controller box right before putting the lid on it. So I've got the board mounted to the bottom of the controller that I trimmed up, and I've got that glued down into the bottom of my project box here. I also glued all of my solder points to really strengthen those wires to keep it from coming undone. And I pulled my cables back through and tightened my cable glands down, so now I can pull on these and they won't come out. So everything's looking good. Now all I need to do is put the lid on my box and put the 4 screws in. And now we have a completed controller box that we can now connect to our modular controller. And there you have it. We have our finished Sega Genesis Mini controller. I did go ahead and put a sticker on it so that I know that this is a Sega Genesis Mini controller, and I also identified the pin numbers on my D-sub connector that each button corresponds to. And I've done this, I've got plans to do this for other controllers on the Brook board and all that, and I've documented that so that I can keep this straight and I keep it consistent among the different controllers. One last thing, since this is a USB controller, even though it is for a Sega Genesis Mini, the Sega Genesis Mini does use USB interface on the controllers, which is really nice because the controllers also work on a PC. So you could use this same controller on a PC if you had emulators for like a Super Nintendo system or a regular Nintendo system or some other gaming system that use similar buttons like this. This controller will work for that. You just have to map the buttons that you want to use in the emulator. And you could probably play other games as well. I don't know if Steam, the computer games in Steam and whatever are probably all too complex for a simple controller like this. But maybe there are games out there that you could use something simple. So that's gonna do it for this episode. We're going to try this out. This will be the first controller that we try on our modular controller, which I haven't quite finished yet. I had to order different parts and do some replanning, so I'm gonna get on that next and get that going, and then we'll connect this guy to that and see if it works. If you haven't done so already, please like and subscribe. Follow along as we go and make different controllers like this. If you have some ideas or want to see certain controllers done up like this that we can try it out with a modular controller, let me know down in the comments. If you have any suggestions on what we can do, start thinking about different buttons and switches that you'd like to see used with the modular controller, and I'll see if I can come up with something cheap and readily available that you can use with that. I'm going to put all the links to the different parts that I used to make this guy down in the description, so check that out. Really appreciate you watching. I'll catch you next time. Thanks, guys.